In the previous lessons, we learned how to use this stoichiometry flowchart based on the given and the unknown, and to determine where we start at the boxes and what conversion we multiply, or the arrows, is basically on two things. That is, of course, for the given we have the number, but most importantly is that the unit and the chemicals. And of course for the unknown, of course we are looking for what is that number gonna be, but every unknown should have a unit and a chemical. And it is of course chemical B, and it is of course chemical A. Now in this lesson, we are going to look at this part of the flowchart right here, or that part of the flowchart right there. But in this case, for GenChem, we're only looking at this part. How are we going to use that conversion factor right there? This conversion factor is called molarity. And molarity is basically the number of mole A equal to 1 liter of solution. So let's talk more about molarity, okay? So let's get over here. So molarity is a unit of concentration. Basically, every solution that you use has a specific concentration, and molarity is a conversion factor. But what is concentration? Well, think of the term concentrated. If something is concentrated, it has a lot of it. Well, in this case, in chemistry, we express in terms of the number of mole. And of course, that is the chemical right there. And we have a certain number of moles in 1 liter of solution. So to demonstrate that to you, notice how I have water right there, okay? So if I were to make this is pure water, okay? Let's make a solution. How do you make a solution? You just mix two things together, and they would dissolve each other. In this case, I have this right here. Look what happened. See right there? It is somewhat light blue still, right? But what happened when I added more of it? So now I have more number of moles. Look what happened to the color. It gets darker and darker. That means it is more concentrated because it has more moles of it in there. Even though the volume stays the same, but you have more of the substance. So therefore it becomes more concentrated. So what does it mean? That means the higher the molarity, that will equal to greater concentration. But one of the most important things about molarity is that molarity is actually a conversion factor. So this is a conversion factor, okay? So what is a conversion factor? Of course it has two parts. Notice how we have number of mole A equal to the liter of solution. So let's do some example problem. In this case, interpret the following concentration as conversion factors. So I have 0.5 molarity of HCl. And how would I express it as a conversion factor? Of course, think of molarity again is equal to the number of mole divided by 1 liter. So what is the liter of? Of course, it's the liter of the solution, which include HCl and water. And most solution is basically just the substance plus water. Well, in this case, we have 0.5 molarity of HCl, so we have 0.5 mole. See right there? We just interpret it as in this form. So mole of what? What's the chemical? Of course, HCl equal to what? Always equal to 1 liter of solution. And of course, I abbreviate solution SOL. Isn't that easy? How about this one? We have 2.0 molarity of acetic acid, which is C2H4O2. And look at the molarity part. And if we look at molarity part, of course, again, it's equal to the number of mole divided by 1 liter of solution. So in this case, if it's 2 molarity of this, of course, we're going to have 2.0 mole of C2H4O2 equal to how many liter of solution? Always equal to 1 liter of solution. And then over here we have 1.0 molarity of NaOH. Of course, again, this molarity is equal to number of mole divided by 1 liter solution. So we have 1.0 mole of NaOH equal to 1 liter of solution. Isn't that easy? Again, molarity is number of mole divided by 1 liter of solution. And over here we have 1.5 molarity of H2SO4, which right here again, molarity is equal to the number of mole divided by 1 liter of solution. We have 1.5 mole of H2SO4, okay, equal to 1 liter of solution. So isn't that easy? Now let's learn how to apply this conversion factor of molarity in stoichiometry. How many moles of HCl, okay, so asking how many moles, that would be our unknown right there, are required to make 2.0 liter of 0.5 molarity of HCl. Whoa, this is getting more interesting, isn't it? So if we look at our flow chart, okay, this is our given, but then right here, this is where the puzzle is gonna be. See how we have 2.0 liter, okay, and that would be where on the flow chart? That would be right here. So this is the liter. But then we also have the molarity part right there. Okay, so what does that mean? Isn't that part right there? So in this case, we combine them together, so we are given the conversion factor. So in most cases, we had to look for this conversion factor, but now it is given to us. So this is our given value, but this is the conversion factor. So how does that work? Well, of course, this is going to be our given. Okay? So we have 2.0 liter of solution. Okay? Well, I'm going to put the word solution there for you. And time this right here. This is our conversion factor right there, which is that one right there. This is actually equal to 0.5 mole of HCl equal to 1 liter of solution. So if we take that, starting right here, and multiply by that conversion factor, which is 0.5 mole of HCl equal to 1 liter of solution, and then we will get our moles. Isn't that easy? And that's all it is. So let's rewrite this as a fraction. So we have 2.0 liter of solution time, notice how this is liter of solution, so the liter of solution on the bottom, which is 1 liter of solution. And what's on top? The leftover part, which is 0.5 mole of HCl. And you divide that together and that cancel out. And we have 2 times 0.5. What is 2 times 0.5? 2 times 0.5. That gives us 1.0. So it's actually equal to, so we have 1.0 mole of HCl. So how many mole do we really need? Turn out to be 1 mole of HCl. So in this case, we would need 1 moles of HCl to make 2 liter of 0.5 molarity HCl. And that's all you have to do. Isn't that easy? The same thing like we did before, using the stoichiometry flowchart. Are you ready for something more challenging? Let's try a more challenging one. How many grams of C2H4O2 are required to make 1.5 liter of 2.0 molarity of C2H4O2, and given the molar mass of 1 mole of C2H4O2 is equal to 60.1 grams of C2H4O2. Well, that's a mouthful. But we know that this is our unknown. Isn't easy. And, okay, we are given how many? 1.5 liters. Okay? And every time you see molarity, just like you see molarity up there, that is your conversion factor. So keep that in mind. So that's where the tricky part. Some of you might think that 2.0 molarity is actually your given, but it's given as a conversion factor. Just like how I gave you your molar mass right there, right? But this is truly your starting point right there. So in this case, our given is liter of solution. Well, how do I know a solution? Because the volume for molarity is always relative to the solution of it. Okay, that's how I know. So in this case, let's go back to the flow chart. This is where we start. okay? And where do we end? We are looking for grams and 1. And notice how this is the same chemicals as your unknown. So therefore, we must stay on the same size, okay? So this is where we must end right there. So what does that mean? We had to go down this way and go up that way. So that's our first conversion factor. This is our second conversion factor. So that is the pathway for it. So let me write this problem out. Of course, always the same format as up here. So we are going to look for question mark grams of C2H4O2. And that is equal to what? Your given times the conversion factor, which is your given is in this case 1.5. So we have 1.5 liter of solution, okay? When it comes to molarity, it's always about liter of solution, okay? Times the first conversion factor, which in this case is that one right there. So we have number of mole A equal to 1 liter of solution. But let's look at that. Let me copy it down for you. Number of mole A, which we know is C2H4O2 equal to 1 liter of solution. Now, do we know that number? Well, of course, right there. It is given to us right there. It's a 2.0 molarity. So that number must be 2.0. Isn't that easy? And that's the reason why we need to realize that molarity is actually a conversion factor. Now let's move on to the next one. It's this one right there. So we time that conversion factor, which is equal to 1 moles of A equal to the number of grams of A. So we have 1 mole of A equal to the number of grams of A. But what is A in this case? It's the same chemical, so it must be C2H4O2. So this would be C2H4O2 as well. But what about that number right there? Well, of course, that is your molar mass right there. So which is 60.1 gram. And that's it. That's all we have to do. Now we just have to rewrite this as a fraction. So let's rewrite starting right here. 1.5 liter of solution times this first conversion factor. So if this is a liter of solution, the liter of solution must be on the bottom, so that way they cancel each other out. Exactly 1 liter of solution. And this on the bottom, this part must be on top. So 2.0 mole of C2H4O2. Notice how the liter of solution cancel out. Then we go on to the second conversion factor. Notice now we need to cancel moles of C2H4O2, so the mole part will be on the bottom, which is exactly 1 mole of C2H4O2, and on top part must be the leftover, which is 60.1 grams of C2H4O2. And look at that, that cancel out. Isn't that nice? And all you have to do is multiply everything on top. 1.5 times 2.0 times 60.1 divided by 1. So let's do that. 1.5 times 2 times 60.1 give us 180.3. So we would have 180.3 grams of C2H4O2. So we would need that much grams to make 1.5 liter of 2.0 molarity in terms of concentration of C2H4O2. And later on, we're going to learn how to do that in our labs, okay? Now let's try another challenging problem. How many grams of NaOH are required to make 1.5 liter of 1.0 molarity of NaOH? And the molar mass of NaOH is 1 mole of NaOH equal to 40.0 grams of NaOH. So again, we are asking for how many grams of NaOH. Of course, that would be our unknown. And that would be question mark grams of NaOH. And what are we looking for? Of course, is that one. But what is given to us? So we need to make 1.5 liter. Well, that 1.5 liter is of solution, okay? Remember, we're taking a substance, put in water. Remember, we are trying to taking a substance, put in water, and we are making a solution. And in this case is the solution of NaOH with the concentration of 1.0 molarity. This is right here is our given. You see right there, when every time you see molarity, think of that as a conversion factor right there. Because molarity exists as the number of mole A equal to 1 liter of solution. So in this case, this is a conversion factor that's expressed in terms of 1 mole of NaOH is equal to 1 liter of solution. So keep that in mind. That's where the tricky part. So in this case, we are using our flowchart. We are starting from where? We are starting from 1.5. We are starting from 1.5 liter of solution, which is right here. This is where we start. But where do we end? We are ending at the grams of NaOH, which is the same chemical. So this is where we end. To go from here to there, we had to go down and go up. See how that works? So we had to multiply by this conversion factor followed by that conversion factor. So let's write this in terms of that format right there. So what are we looking for? Question mark, gram of NaOH equal to the given, which in this case is 1.5 liter of solution, times the first conversion factor, which is 1 moles of A equal to the liters of solution, which is the number of mole A equal to 1 liter of solution. So we have number of mole A equal to 1 liter of solution. Well, in this case, that number right there is actually your molarity. So it's not just a number, but it's actually 1.0 mole. So see how that's being used as a conversion factor? Then we multiply to the second conversion factor, which is 1 moles of A equal to the number of grams of A. So we have that. We have 1 moles of A equal to the number of grams of A. So let's use a different color. How about that? Now let's rewrite this into a multiplying a fraction. So in this case, well, what about our number of grams A? Well, what is A in this case? This is your chemical, NaOH. And this is the same thing, NaOH, because we're not changing from one chemical to another chemical. And what's the number of gram? That's the molar mass, which is 40.0. Now let's rewrite this as a fraction, okay? So 1.5 liter of solution time. See that right there? Which part is going to be on the bottom? Of course, it has to be the same as that part. So we have 1 liter of solution on the bottom. They cancel each other out, right? And the top part would be the leftover of this conversion factor, which is 1 moles of A. What is A in this case? Is your NaOH. So this is NaOH, okay? Time our next conversion factor, which is this one right here. If this mole of NaOH, down here has to be the same, which is 1 mole of NaOH. What's on the top part would be 40.0 grams of NaOH. And there you go. Isn't that easy? And moles of NaOH cancel each other out. And what do we have in the end? Multiply everything on top. So which 1.5 times 40.0 grams of NaOH divided by 1. But we can ignore the 1. So we have that turn out to be 1.5 times 40.0 give us 60.0 gram of NaOH. So to make 1.5 liters of the concentration of 1 molarity of NaOH, we need exactly 60 grams of NaOH, adding into 1.5 liter of water. Isn't that easy? Isn't that easy? Let's try another challenging problem. How much water is needed to make 0.5 molarity of NaOH with 1.5 moles of NaOH? And which, of course, we are given the molar mass of NaOH. So this is how much of water. So that is question mark. Water. Remember, we need water to make a solution. So this is basically asking how many liter of solution is going to be. Okay? And it's needed to make 0.5 molarity. That tells you there is your conversion factor, which is 0.5 mole of NaOH equal to 1 liter of solution of. So again, molarity is given to you as a conversion because that's what it is on the flowchart. It's not in one of the box. You see how that? There's no such thing as box of molarity. There is only the arrows of molarity, just like the molar mass. And here we have 1.5 moles of NaOH. That is our given right there. So in this case, we are starting from our moles. Okay, that's where we start. And where do we stop? We are looking for liter of water. So in this case, that is the solution. So this is where we end. So to get from here to there, we just need to multiply by that one conversion factor. Isn't that easy? So let's set this up. So of course, the same setups like this. What is the unknown? We are looking for question mark liter of solution. Well, the solution is made of the volume of water because the substance is too small to make any volume changes. And that is equal to the given, which is 1.5 mole of NaOH, okay, time the conversion factor, which is number of mole A, equal, that's the molarity concentration right there, or that is the molarity conversion factor right there, equal to 1 liter of solution. Okay, and do we know what is that number is going to be? Of course it's given to us right there. It's actually equal to 0.5. And that's it. That's all we have to do. Now let's rewrite this. 1.5 moles of NaOH time. If this is mole of NaOH, on the bottom part would be the mole of NaOH, which is A right there. So let me read that for you. Isn't that easy? So 0.5 mole of NaOH. On top would be 1 liter of solution. Notice how the mole of NaOH cancel out. And all you have to do is multiply everything on the top, divide by the bottom, which is 1.5 divided by 0.5, equal to 3.0 liter of solution. So to make 0.5 molarity of this NaOH using 1.5 mole, we need that much volume. So this is 3.0 liter of water, or 3.0 liter of solution. And 100% of the solution by volume is water. So, or H2O. Because 1.5 moles in terms of volume is extremely small compared to 3.0 liter of volume of water.